Hello students, today we are going to discuss yet another important topic which is known as free body diagram. Free body diagram is very much important, especially in mechanics. To solve all the mechanics problem, we have to make a free body diagram, and thereafter only we can able to solve the problems. So without further delay, let's get started. So what actually is the free body diagram? Let's understand that. So in a free body diagram, we actually represent all the forces acting on a body with their directions. Okay, so that is the main goal of a free body diagram, so that we can understand how many forces are acting and in what direction. So you can see a block over here which is kept on a triangular wedge. This is black color. This you can see the wedge, triangular wedge, on which we have kept a block. So there are certain steps we have to define and we have to follow while making a free body diagram. As I just now explained, free body diagram is a diagram in which we draw all the forces acting on the body in their directions. So let's say if we have a body like this, which is kept on a horizontal plane. This is your horizontal plane, and we need to make a free body diagram of this particular body. So what we have to do? We have to draw all the forces acting on this body. So what are the all forces? Of course, it has a weight. So weight will be mg, which will be always acting towards gravity. And what is the direction of gravity? Always downwards. So this is the direction of gravity g. So weight will act towards g. And since weight is acting on this horizontal plane, it will have reaction, normal reaction, because of the gravity, Newton's third law. Okay, so this is the normal reaction. So these are the two forces acting on this. It's a stationary block, it's not in motion, so they will always be balancing. So n is equal to mg. So that's the free body diagram of this stationary block. It's not in motion. Alright, so that's just basic understanding of a free body diagram. So in most of the cases you will get a body or system in which it is moving. So I just took an example where it is not moving, it's a stationary block. So we identify the forces, what are the forces acting on this, and then we draw them in their direction of action. So what is the first step? First we need to identify the system on which you have to draw the forces. Secondly, we have to identify the forces acting on that, and thirdly we have to draw those forces in their respective directions. So these are the three important steps we have to follow. So let's take an example of this particular system. In this system, as I explained, there is a body, this mass, which is kept on a triangular wedge. It is sliding down. You can see there is an acceleration shown here in this direction. So the block is going to move in this direction, right? And this wedge has an inclination angle of theta. Okay, so it's going to slide down. So first we have to identify the system. What is the system? First step is identify the system. Identify the system. Which system you are going to use to draw the free body diagram. So in this case the system is this block. This is the focus area. So our system is the block. This is our system of concern. Now the second step is we have to identify all the forces acting on that system. What are all forces? Identify all the forces. Identify all the forces acting on that particular system. Alright, so these are the first step. which we have to follow. So we are at second step now. So in the second step, we have to identify all the forces acting on this particular block. So what are those forces acting on that particular block? We can see by our understanding, if something is placed on some other block. So here our system, which is red block, which is kept on this black wedge, of course the weight will be acting, right? Weight of this block will be acting downwards. That will be the first force of that will be the first force acting. So what will be the first force? Weight of that block. What is the second force? So second force will be, since something is the weight is acting downwards, then that weight will cause a reaction force of also. That's a Newton's third law, right? Every action will cause a reaction. I will talk about the direction of the forces later on. So let's identify the forces first. So reaction force, because of the weight, reaction force, which is N. So these are the only two forces acting right now on this particular system. Now this weight mg will act downwards. Just now we understood in another example which I drew over here, the picture. Weight will act downwards towards gravity always. We all know that. So gravity direction is towards downward. You can see here G, direction of G. So weight will act downwards here. N, which is your normal reaction, which will that will always basically act perpendicular to the plane where the block is kept. So in earlier example, where block was kept at rest on a horizontal plane, this was your horizontal plane. I was just giving an example. Weight was acting downwards like that, and reaction was upwards like that. So this weight mg was responsible for this reactive force. So this reactive force or reaction force is acting perpendicular to the plane. This is the plane on which block is kept, right? Now come back here. Here your block is kept on this inclined plane. So reaction will still act perpendicular to the inclined plane, basically perpendicular to the plane where block is kept, not in this direction, not vertically up. Here it was vertically up, but it is perpendicular to the inclined, perpendicular to the plane it is kept upon. Here also it will be perpendicular to the plane it is kept upon. Okay, so keep this thing in mind. So reaction force will always be perpendicular to the plane the block is kept upon. So this is the direction of reaction force, and this is the direction of your weight. This is your reaction. Now we all know by the resolution of vectors, this will be mg cos theta, this is theta, then this will also be theta. Alright, so this becomes mg cos theta, this becomes mg sin theta. This mg sin theta is force acting in this direction along the plane. Now for the ease of understanding, or for ease of our solution of this problem, when acceleration A is going to this block is going to be accelerated by acceleration A, so we need to use equation of motion. So basically the Newton's law, we have to apply Newton's law on this block. So how do we do that? So in order to do that, first thing we have to do, we have to always draw axis x and y. Okay, so that helps us to find the forces responsible for the motion along the axis where the motion is happening. So first axis is x, which is along this axis, along the plane, because block is going to move along this plane. So take your x-axis along the motion first. and y-axis will always be perpendicular to x-axis, so there is no concern for y-axis. Choose your x-axis accordingly. In the sense, x-axis you should always choose along the motion. Our motion is in this direction, so I have chosen x-axis in this direction, and for y-axis there is no doubt, because y-axis is always perpendicular to x-axis, so that's by default. Okay, so these two axes I have chosen like that. Now if something is moving, so we know according to Newton's law, the net force will be responsible for that motion, and that will be equivalent to m into a, right? So what are the net force along the x-axis? In this case, if I say sigma fx, meaning that summation of all the forces acting in x direction. So in x direction we can see only force acting is mg sin theta, no other force is acting, right? So sigma fx will be equal to m into a, right? That's the Newton's law, which I can say mg sin theta will become m into a. So mg sin theta comes from summation of fx. So m cancels out, so we get g sin theta is equal to a. So that's your first equation. Similarly, in y-axis we can say sigma fy. We have to sum up all the forces acting along y-axis will be m into a, right? But what we see here, there is no acceleration along y-axis, so there is no movement, right? This object is not moving along y-axis. This object is moving only in x-axis. So this will be 0. A will be 0. A will be 0. Correct? So what we can say? We can say all the forces summing up in y direction will become 0. So what are the forces acting in y direction? N minus mg cos theta. These are the forces acting in y direction, which will be equal to 0. So n and minus mg cos theta is downward, so minus mg cos theta will be upward. So that will give the total force along the y-axis, which gives you the value of n is equal to mg cos theta. So that's the reaction we get here. This will be the reaction, this will be acceleration. All right. So this condition you see when there is no external force, I mean there is no external force acting on the block, only it's just simply kept on a triangular wedge which is inclined. So of course it will start sliding down, so acceleration of sliding will be g sin theta. So that's pretty much simple. But what happens when we start applying some external force or some friction is there? In this case, whatever we talked about so far, there was no friction. We considered the surface is frictionless, so friction is not there. At the same time, there was no external force also. External forces are 0 and friction is 0. All right, so let's talk that case also. It will be much more clear on the free body diagram front. Okay. So when friction force comes into picture, first thing you have to memorize or remember, friction force always acts opposite to the direction of motion. That's the point you have to take note. Friction force always acts in opposite to the direction of motion. Alright? So if this is moving in this direction and there is a friction between block and wedge, then friction force will be other side, opposite to mg sin theta. So let's say friction force will be like this. Friction force. Since this is moving in this side, then friction will be that side, right? That's very much clear. Just now I told you about that. And Also, if I apply some external force, capital F for that matter, I will make another force in this direction, which is capital F. Okay, so we are pushing from top by force F, and friction force is that side. So what are the net forces acting along x direction now? So of course sigma Fx will still be ma. We know that according to Newton's second law. So let's compute the value of Fx now. All the forces in x direction. So mg sine theta, that's the first force. Second force is F plus F. This is in the x direction, so it will be plus F. And F, this small f, which is friction force, that is opposite to x direction, basically the other side. So this when I take into the direction of x, it will become minus f, right? So this is the net force along x axis. This will be your ma, correct? So this is how we consider external forces and friction forces. This is your friction force. And for sigma Fy, which is your 0, there is no movement in y direction. That still remains unchanged. There is no additional force here. Still same forces, n and mg cos theta. So n minus mg cos theta is equal to 0. So this is your first equation, this is your second equation. So this is how we draw the free body diagram, and finally after drawing the free body diagram, we resolve the force vectors accordingly and find the required parameters. I hope this is clear, very much straightforward. Only thing you have to keep in mind while solving these kind of problems, make sure your direction of forces is taken correctly. There is no mistake on those things. All the force vectors, when you draw, you have to draw it in a right direction, and when you do sum up basically Fx and Fy, you reverse them. Like for F, small f, which was your friction force, I reversed it because that was in opposite direction of x. So those things you take care, and your net force you have to take Fx in the x direction, and that will be equal to ma, because Newton's second law says that net force F is equal to ma, right, where F is the net force acting on the body along the direction of acceleration. So we have to find the net force acting along the direction of acceleration. So this is the net force along the direction of acceleration, this is the direction of acceleration, and this is the net force along the direction of acceleration. So you have to be very careful. You should not take any other component in x direction, only the components of forces, all the forces which are acting along the x direction. So all those components you have to consider and equate them with ma, right? So the steps to draw the free body diagram, and then finally making the equation, I will just reiterate. First we have to identify the system. In this case the system is this one, the block. Secondly, we have to identify the forces acting on them. In this case, now there are more forces. Earlier only two forces were there, weight and normal reaction. Now we have weight, normal reaction, external force F, and frictional force. So those forces you have to identify carefully. You should not miss any force, otherwise answer will not be correct. So identify all the forces correctly with their directions. So make sure direction you derive correctly. Read the question carefully, and then find Fx, sigma Fx and sigma Fy, whereas Fx is sigma Fx are the forces acting along the x direction, and sigma Fy are the forces acting along y direction. And direction x you have to take along the motion of the object, and direction y will be perpendicular to the x-axis. Okay, so I think this is pretty much simple, and if you have any question, please drop a comment in the comment section below. I'll be happy to answer you. Let me know if you want to know something more about free body diagrams or Newton's law. I'll be happy to make some additional video on that. Thank you so much.